This video is for the 10-4 practice problems on the back side of the notes for lesson 10-4 on solving equations using various methods. So here we go. We'll go through and practice solving some equations. This video should cover probably problems 1, 2, and 3. And then you can go to the next video if you need to see something from 4, 5, 6, or 7. All right, so the first one we have is 7 to the power of x plus 3 equals 343 to the power of x. So this one is like an exponential equation. This is like lesson 10-3. Remember, the first thing we have to do here is we have to compare the bases. And since our bases are not the same, we are going to need to use that rewriting method. Okay, so when we look at 7 and 343, okay, let's look at the bigger number, 343. Can we write 343 as 7 to some power? Right, so let's figure out what power that would be. So you can get out your calculator, right? And all I'm going to do here is I'm going to take 7 and I'm going to raise it to, we know 7 to the power 0, right, is 1, so that's not it, obviously. We've got 7 to the first power is 7. That's not going to work. 7 squared is 49. 7 to the third, you see, is 343. That's the one we're looking for. So we know that 7 to the third power is the same thing as 343. So we go back over to our equation, right? I've got 7 to the power of x plus 3. And all I'm doing is changing that 343 to a 7 to the third power. Okay, so we just basically changed this to this. Now we're going to apply our exponent rules, right? Raising a power to a power, we multiply. So we have 7 to the power of x plus 3 is equal to 7 to the 3 times x, which is 3x. And now that both of the bases are the same, we'll pull out our exponents and set them equal and solve. So subtract x from each side. And we're going to get 3 is equal to 2x. We'll divide by 2. And it looks like we get 3 over 2 is equal to x. Or if you're more comfortable with saying 1.5 equals x, that's totally fine. And if you want to check them, right, if we plug that 1.5 back in, right, on the left side, we'd have 7 to the power of 1.5 plus 3, which is, what, 7 to the 4.5 power? Okay, and then on the other one, we'd have 343 to the 1.5 power. Let's just type those into Desmos and see what those values are. So we've got here 7 to the power of, what we say, 4.5. Ooh, that's not a very pretty number, but right, it is what it is. And then we're going to do 343, and we are going to raise that one to the power of 1.5. Like I said, not a pretty number, but they're the same number, so we know that it is correct. So we don't even worry about what it equals. As long as we've checked on the calculator, we know we're good. So our answer there was x equals either 3 over 2 or 1.5. All right, so we use rewriting on that one. Let's see what happens on this next one. We have 2x minus 8 over 10 is equal to 6. And honestly, I'd probably end up using rewriting on this one as well because I don't like having fractions. So we could get rid of the fractions in this one. Let's look at starting out here, right? Treat your 6 like it's over 1. And everything on the other side is over 10. So our least common multiple between 10 and 1 is 10. So we're just going to multiply both sides times 10. So we have 10 times a 2x minus 8, right, over 10 is going to equal 10 times 6, which is 60. And since it's over 1, I'll just leave it as 60. Now remember, we've got a common factor. Those 10s are going to cancel. So we're looking at 2x minus 8 equals 60. And now let's just do our two-step equation. Add 8 to each side. We have 2x is equal to 68. And then we are going to divide each side by 2. And we get x is equal to 34. So now we can take that. If you want to check it, let's see what happens here. I'll do that in blue. 2 times 34 minus 8, all divided by 10. We're saying that should equal 6. Let's see what happens. 2 times 34 is 68, and 68 minus 8 is 60. So we have 60 divided by 10 is 6, which is true. 6 equals 6. We know we're good. All right, let's go ahead here now and look at number 3. 3 says 4 plus, and then it has a quantity there, and it says x divided by 3 equals 9. It's not very often that we see actual division sign like that, right? Usually don't we see a fraction? So let's go ahead and rewrite it so that we can actually look at it that way, right? So I'm not really using the rewriting method, I'm just making this look more familiar, right? In fact, I would probably end up starting out with looking inside because I'm adding 4 plus something equals 9. Well, 4 plus what equals 9? Right? If you said 5, you're correct. So I know here then that this x over 3 has to equal 5 in order for the equation to end up equaling 9 above. And then if I'm doing x divided by 3, right, I can undo divided by 3 by multiplying both sides by 3. So 3 times x divided by 3 should give us x, and 3 times 5 is 15. So it looks like our answer for this one is 15. And if we plugged it in up here, 4 plus 15 divided by 3 should equal 9. That gives us 4 plus 5 equals 9, and we know that's true. So there are the answers for numbers 1, 2, and 3. We got 1.5 for number 1, 34 for number 2, and 15 for number 3. If you have additional questions, please make sure you ask the teacher, reach out to me at some point, or go to Math Help. Thanks for watching.